So welcome to everybody who's already here. And today we are having a small webinar from Wipro 3D on the focus areas as per national strategy for additive manufacturing, along with some case studies. We're also focusing a little bit on the global market and what the global strategies are, things that are being done around the world in additive manufacturing. Our presenter today is Akshatha. Akshatha has around 15 years of experience working in industry, with 8 years specific to additive manufacturing. She works in Wipro 3D. And some ground rules of this webinar. We will have all questions through the chat box currently. We will have a 10-minute slot right at the end where we will be answering specific questions from the participants. We will unmute participants based on the questions they have asked during the time we're responding, so we can have conversations with them as well. With this, I hand it over to Akshata. Akshata, you can go ahead and start. I see that somebody has their hand up. Let me just quickly check that. Mr. Ravi Kiran has his hand up. Mr. Ravi Kiran, I'm allowing you to speak right now. You can please go ahead with your question. Or you can leave it in the chat box if you're unable to unmute yourself. Okay, I see his hand has gone down. So let's go ahead and start, Akshata, and welcome everybody. Thank you for joining.
Welcome everybody again. So I will continue with my introduction a bit. So I work in Wipro 3D as the Advise leader. The Advise offerings from Wipro 3D mainly concentrate on knowledge transfer, trainings, workshop with regard to additive manufacturing. And we are a part of the Wipro 3D group, which then is a bigger part of the bigger Wipro group. Like the topic of the session was, today we will go through these three sections in our webinar. The first one is global adoption of AM, wherein we have tried to put together some of the case studies or use cases across the globe, and we will see how different people are adopting AM and in which way. We will follow that up with a brief summary, you can say, about the national strategy for additive manufacturing. This is a policy that was released by the government of India. And like you see, when there is this kind of a policy or a strategy that is coming out for additive manufacturing, it definitely means that there is a lot of focus on additive manufacturing in India. And so in the third and the last part, we will connect that to some of the use cases and case studies that have been adopted in India, and we will conclude with that. So without any further delay, we will go ahead and explore some of the use cases around the world. And I start with one of the use cases from Volkswagen, so an automotive customer. And Volkswagen is using additive manufacturing in its production lines very often. So when we say automotive, most of the times the questions that may arise in your minds are, is additive cost effective? Can it make parts that fast? Can it make it at an economical price? And these kind of questions. But Volkswagen has found a way of using additive manufacturing in their assembly lines, in their factory for their production. So what they have been doing is that they have this army of printers, mostly material extrusion. You may identify that as an FFF printer or an FDM printer. So they have an army of these printers, and then they usually print overnight a new tool or a fixture or a jig, which will help their assembly process and saves them a lot of time. So the advantages that they have found with this is that they can come up with custom designs as and when they think of an improvement in the design and that they want to do. They do not have to wait to give out the order to somebody else and then get the fixture or the jig or something like that. They just print it overnight and it is ready for use the next day. They're also seeing that it takes far less time, and they have put together the numbers and have come up with the fact that they have been saving a lot of money because they are printing this in-house as well. So this is one way of adopting AM. It is not required that you only have to make different components of an automobile, but this is an indirect way of using additive manufacturing in an industry like a automotive industry. With this, we're also seeing that material extrusion, which is also called as FFF or FDM, is widely adopted. It is a technology which people are using to make many number of parts. Some of the advantages of this technology is that it is very easy to adopt. You can start printing with it very easily. And also, this is a kind of a low hanging fruit, which means that it isn't too much of an investment to buy the FDM printer and start using it and see if this works in the organization to see if it adds any value. So it's easier to adopt, right? And the raw material for this is basically wires, and you get the raw material also in different colors and at different costs and different kinds of material. So with this case study, I wanted to bring forward how one could adopt additive in a cost sensitive but a big market like automotive, and how FDM technology is being used. So continuing with polymer applications, I would like to discuss about two other applications here. One is a joystick, which is used in gaming, and the other is a shoe sole. The joystick over here, it has been made by the SLS process. The material is nylon 12, and the shoe sole that you are seeing there is being done with the DLP technology. So polymers again are finding a lot of applications in different industries for different reasons. It could be something like an ergonomic design, enhanced performance. It's also a market differentiator in certain ways. Now, while we are on the topic of this Adidas shoes and a shoe sole, I also want to emphasize on the fact that these additively manufactured things like the shoe sole, but also we've seen examples of guns, which are used for the shooting sport, some bicycle frames, eyewear, kayaks, surfboards, some prosthetics kind of things for sports people who are physically disabled or challenged, racing car components which are custom made to a certain racer, helmets for them, seats, and these kind of things. So polymer additive manufacturing through any of the technologies, this is just an example of SLS and DLP, but with various technologies, they are processing this and using it a lot in the sports industry as well. So we looked at automotive, we looked at sports, and now I want to go into one sector which is very, very sensitive about certification and qualification and testing and all of these requirements. So these industry verticals require a high degree of testing and qualification criteria. One of them is the aerospace industry, which includes both the aviation and the space industry. Here is an example from Orbx, which is a UK company, and they have printed the largest rocket engine with composite and also aluminium, right? So they have done this in UK. But we've seen this repeat in many of the other cases. There are space agencies all over the world are printing a lot of their components with additive. So some of them may be in the rocket engine, which is super critical, and then, high pressures, temperatures. So you have to do extensive testing and all of that. And some of them are also printing really, really large parts, like the entire nose or the nozzle of the rocket. So Relativity Space is based in US and they are doing that. Another area where the space industry uses additive manufacturing is the satellite communication, so antennas and other related components. When it comes to these industries, there is a lot of confidence on laser powder bed fusion technology, given the fact that we have quite some material data on it, and hence confidence on the performance of the parts that are printed through this technology. And when we look at really large parts, then again, we see that technologies like DED, direct energy deposition, get used for those kind of applications. So here we are seeing that even metal is being adopted, and in industries which are quite critical when it comes to the certification and qualification. The advantage that these aviation and space industries find in case of additively manufactured components are that they're able to realize designs which are very complex, but which enhance the performance of the component itself, right? And another advantage is that they kind of consolidate a lot of components into a few components, if not one. And this helps in simplified manufacturing. So you do not have the hassle of contacting many vendors, putting it together in an assembly where sometimes you have failures and things like that. So this is leading the way for simplified manufacturing. Another advantage is that for space applications, you do not need too many number of components of the same type, and they can change the design very often as well. So these are all the benefits that the aviation or the space industry is reaping from additive manufacturing. With this, we move to another industry vertical, which has been a very early adopter of additive manufacturing, which is the medical. Now, the picture you see here is of an implant. It's a spinal implant. And this is one category of components that are being made. The other category may be surgical guides, instruments, and these kind of things. So it's not only implants, but yes, when it comes to implants, mostly it is metal that is used. And the technology that is being used could be laser powder bed fusion, or it could be electron beam powder bed fusion. So I wanted to detail out the metal technologies as laser powder bed, electron beam, and in the next slide, you will also see DED. Because these are the technologies which are the most mature to print metal parts. Now, the medical industry reaps another set of different benefits from additive manufacturing. It could be enhanced design, wherein you have the possibility that the bone growth, the tissue growth with these implants has been much better. It could be customization. Customization is much necessary when it comes to trauma cases. For example, if somebody has had cancer and had to take away a part of their jaw, or they've had an accident and had to, have a part of their skull replaced and things like that. And this is one industry where the cost aspect of additively manufactured part definitely competes with the conventionally made part. And if you had to get that kind of a texture and the customization in a conventionally made implant, it would involve a number of processes, and hence the cost would be higher. So it's probably costing much lesser to make these kind of enhanced designs and customizable implants in additive manufacturing. So I'm only hoping that in the coming days, even the other industries will start to leverage this benefit from additive. So the last global use case that I wanted to bring to you was this really big bridge that has been installed or assembled across a canal in Amsterdam. This was printed by a company called MX3D, and it's a steel bridge. They printed it in parts and they have put it together. So the reason I wanted to put in this slide is to just show you how big it can get. So additive is not only for small parts, but also for really big parts. The technology that was used for this is direct energy deposition. With regard to DED, one another aspect that I also want to stress upon is that one thing you can carry away is large, so you can make bigger components. But the other thing is that the repair is also another application which leverages direct energy deposition. So when parts of the blade are worn out or other components, then you use this kind of technology to repair those parts, refurbish them and use them. So what we've tried to capture in all of the case studies that you just saw is that additive is being adopted across industry verticals. Few years back, we would probably say that aviation and defense is using it. I mean, they can afford to, probably pay a lot of money. It's not cost effective and things like that. But AM has found ways to add value to organization in different ways. Then we see that across materials, additive manufacturing is coming up, as in be it polymers, metals, ceramics, and different kinds of materials. Also, additive manufacturing is making a way there. And there are quite unique and different technologies, and all of these technologies, again, are adding value in their own way. It's not that one technology is superior, the other is not as good. So each one is finding its way in spite of the differences in the technologies. And yes, different people are using additive for different value drivers. So the value one industry or one application derives may be different from the other, but there is a whole range of value drivers across which additive is making its way. So that was the picture that I wanted to give you with all the case studies which we just discussed. Now moving forward, we will discuss a bit about the National Strategy for Additive Manufacturing. This was launched on the 24th of February in 2022. And it has a few main topics that it covers, like the strategy outcome, industry-wise opportunities, adoption barriers, and focus area. We will go through all four of them briefly in the coming slides. But basically, what it says is that we should develop indigenous technological capabilities and should be able to leverage the full potential of additive, and hence the fourth industrial revolution, which is, which is here already, right? So let's go into the strategy outcome. Let's see what the strategy says about the outcomes. They have very specific 6 outcomes that they would like to see. First one is 50 India specific technologies. Second one are 100 new startups. Third one is 500 products. Fourth one is 10 manufacturing sectors. 5 is 1 lakh new skilled manpower. And 6th is awareness and adoption of AM products. So if I try to somehow consolidate this into 3 simple points, then I would say on the top of the list would be innovation and IP creation. And innovation and IP creation needs to happen in the materials aspect, in the machine, in the process, the software, and the design itself. So there is a lot of innovation which needs to happen in the different realms of additive manufacturing. The second one I could say is that there is a vision to set up manufacturing hubs, of AM. And the third one is to develop the awareness of people and also skill people with the additive knowledge. So this is the outcomes that have been discussed in the policy, but they have also identified very relevant barriers. So one of the barriers they mention is processes and performance. If we see today, the processes that are most popular is probably laser powder bed fusion and FDM. And there are some limitations to the process. Let's say when we look at laser powder bed fusion, there is a certain size restriction beyond which we are not able to go. If you look at FDM, then there is probably the speed of print when compared to other polymer AM technologies. So there are certain limitations to the processes and how they perform. So this is identified as one of the barriers. Then we have material as another barrier which is identified. So when it comes to material, the lack of data on additively printed material is definitely a barrier. The range of materials available to be processed through AM can also be considered as a barrier, but there is constantly work going on to increase this range. So these are some of the material related barriers. When it comes to AM ecosystem, and since this policy is specific to India, then we could say that we don't have a lot of powder manufacturers, let's say, for example, or people who can help with some automated support removal or finishing operation or something like that. There may be a few, but it's not a big ecosystem in a way, right? And then the next barrier is the business case. So when we say business case, it is about choosing those right parts which make both economic and technical sense to print, right? Just because it is printable, we will not print it. It economically also it has to make sense, and such cases, business cases, have to be found. Still need to be explored in large numbers. And the number, when this number of printing or cases and all of that increases, then automatically the ecosystem starts to grow, and we will have more and more business cases. The willingness to invest in the new technology, which is also quite an expensive technology, is also probably coming under this particular barrier. The next one is qualification and certification. I think this is a well spoken of or known topic. ASTM, ISO, everybody is working together to bring out these standards for additive manufacturing. There are dozens coming out every year. So this situation will only get better. But right now, yes, it is a kind of barrier. When we come to legal work frames, so the ease of doing business is one aspect of it. How easily, when you want to use it for defense or things like that, there are these paperwork and things that need to be filled out. But also, I think filing of IP is something that needs to be even more simplified and should happen, because innovation, IP, legal framework, all of that come under one big umbrella. Once this is simplified, I think there will be more and more people willing to, file patents or innovate and things like that. So they have identified some of these barriers, but what I feel about this is also that these are all opportunities for people to innovate and research. When we say the material range is not very wide today, it means it is an opportunity for people to work on new materials and bring it into the additive manufacturing range. Or when I say processes and performance, then it's probably for somebody to, innovate and research about what will happen if I put more lasers on a machine, or is there another technology with which I can build bigger parts. So all of the barriers that are listed here are actually opportunities for research and innovation. So this should kind of give us a way ahead, in where is the gap and what can we do to fill that gap. Another very important aspect that I also want to mention while we are on the slide is that every role in an organization needs to understand about AM so that we can overcome this barrier, right? Now, the metallurgist should know about AM, and then he or she will be able to give a solution when it comes to materials. The production engineer or the process engineer should know about the process and performance of the machine to probably tell us how best we can economically use the machine and its accessories so that we can get an optimum cost for the part. The quality people should, be aware of the standards that are there, the gaps that are there, and what we can do to give confidence to the certifying agency that these parts work. Then it could be the managers who would like to know about the way AM parts are costed, or how to select good parts, whom to train first, what should be the path of adoption. So every role in an organization needs to be aware of the AM process and come up with solutions. So this is another aspect that I want to highlight here. I would then like to go over what the policy says about industry-wise opportunities. And yes, again, the policy was made specifically for India. So for aerospace, what they say is that we have a lot of tier 2 and tier 3 aerospace companies here, and we have to cater to them. So this may be something like avionics, right? How 3D printing can be adopted in avionics is probably something we should concentrate on. When it comes to aerospace, I think MRO is also a big field for us to use AMM. So those are one or two things in the aerospace domain that we should put our focus on. When it comes to defense, there is a lot of focus on indigenization and localization of the products for defense. And further in the slides, you will see that we have some examples about how defense sector is using additive manufacturing. So that's also another thing that we should look at. Medical, of course. Then we have electronics. And when it comes to electronics, it may be satellite communication devices or sensors or some special circuit boards, even though it's not the most mature, but it's definitely going to be there in the future. Automotive, and we've seen that it may become that AM parts are directly used in additive in the automobile industry, but there are other ways, like I mentioned, to use additive in the automotive sector. But with all of these advanced mobility options that are coming up, be it self-driving cars or e-vehicles, electric vehicles, uh, and different kinds of concepts coming, definitely AM will start to get used more and more in these industries, not only because of that, but also probably because the adoption of copper and materials like this, which aid in electric devices or electronic mobility, are also now available in additive manufacturing, right? So because of this reason, even in automotive field, it is going to go forward. Industrial includes everything other than what is mentioned here. So it may be oil and gas or tooling or something like that. And we've seen impellers which get used in oil and gas industries being developed through additive. And tooling industry, the conformal cooling channels. So all of these are widely adopted in the industrial sector. When it comes to consumer, we saw a few case studies like the shoe that I showed, or the gaming joystick, and jewelry, gifts, and things like that. So that will continue to use. And construction is also mentioned in the policy. So printing with concrete and for the purpose of making homes or shelters also is mentioned in the policy, right? So every industry that is mentioned here is unique. They will use additive in a very different way, and they will have very different challenges also in adopting additive. So each industry has to be given its own focus and has to be approached in its own way. So with that, I will then move on to the crux of it, wherein I will share with you what we think is the one or two or three focus areas when it comes to this policy. So the policy is saying design wise, we should have new design methods, develop design tools, and also come up with new designs of applications. When it comes to material, production of AM material at a lesser cost, adopting new materials, standardizing the material requirement or vendor qualification. When it goes to process, it's very clear: bigger machines, faster machines, and more accurate machines. And then to have stable, repeatable processes, and maybe to develop equipments also. And for the entire value chain, then what they're saying is develop cost models and tools, qualification and certification, and integration in supply chain. So this will all help in faster adoption of AM. But if you look at it, we think that the focus area is definitely unearthing those applications wherein you can have that most creative, unique design, or that application for which there is this material that can be processed through AM and gives an advantage and edge over everything else that was existing before, or coming up or unearthing that application wherein you need to tweak your process, or innovate with the process to print that part. And again, applications wherein it will drive the value chain to support its adoption. So for us, I think clearly the focus area is finding those applications for AM. So here I've put together about 4 use cases with which I would like to conclude the section of the policy itself. Um, So if you look at the first example, which is the O2 vent, this is from an Australian company. And there is this condition called sleep apnea, where people don't breathe for a certain time, and it's quite dangerous, right? So they have come up with this additively manufacturable design in nylon, wherein you put this in your mouth, and then your muscles won't collapse and you will not lose air. So you keep breathing throughout the air. So there's one innovation there from Australia. I showed you a lot of things from Europe and USA. So I wanted to show you one from that part of the world. And again, from medical, but not metal, and not an implant. Now there is this one more example from Optisys. So Optisys specializes, and its main business is to 3D print, to design first antennas for satellites, which can only be achieved through 3D printing, right? So the component that you see on that palm actually used to be quite big, about a foot long. But with additive manufacturing, they've reduced the size of that component to such a small one. And that design can be achieved only through additive manufacturing, because below you will see that there are some structures there which have been designed to take away heat also. So it's doing multifunction, the same function in a much smaller size, hence giving a lot of payload advantage, right? So here is a company which improvised on the antenna design and now has its own business unit with this AM, right? Now, so the first two that you saw are new companies which are taking advantage of additive, but the third one is a Italian company and it's been there around for quite some time. I think it's from 1982 or something like that. So it's a very old company, very well known to make all these hydraulic blocks. But even there, they have identified some of the manifolds that they can 3D print and now have another division where some of the manifolds that they have identified and qualified are only 3D printed. So even in an existing organization, an old organization, additive can find its path. The fourth one is quite famous, Siemens. And in this case, it's not a new product. In this case, it is the repair of the blade tips. So when the blade tips wear off, then they grind it, put it in the additive machine and they print only the tip of it, machine it, finish it off and reuse it, right? So they have found a way of reusing this, hence contributing to the sustainability aspect, right? So different ways of using additive is what I wanted to bring here. New company, old company, repair, new product, polymer, metal. So that's the range that you can see in this slide. All right, so I will quickly move on to the last section, wherein I would like to highlight how AM is being adopted in India. And what I've done is taking inspiration from the national strategy, I have listed only about 2, 3 areas, but I've made sure I covered most of the technologies, right? Now let's start with defense. So we see that the defense sector in India is willing and is already adopting AM very willingly, right? One of the examples that you see on the top there is a gun for personal defense, and they customize the handle uh, to the person who's using it, and some of the other components they are customizing it. But I think the real value is that, let's say that some component of this gun fails when they are on the field, right? Now they do not have to wait to order the spare parts, get it, or maintain an inventory or anything like that. If they have a printer, they can print different sections of this and continue to use the equipment. So that's one of the values that the defense sector is deriving from it. And if you look at the second picture, it's a house. Yes. It's a double-storied house. Yes. And it is a 3D printed house. So Indian Army recently printed this about 71 square meter area house in Ahmedabad. And this happened in just 12 weeks. So the kind of concrete or cement that has been used has been developed so that you can quickly print one layer upon another and cures in a certain way. So Mycob, MICOB, that's the company which has helped print this particular building. So imagine printing shelters for the soldiers where it's quite difficult to go on transporting material, right? They can build shelters in the remote parts of the country where there's probably not very good transport facilities, etc. So that's another way that the defense is adopting AM. Recently, also in the city that I stay, Bangalore, they've printed a post office using additive manufacturing. The last one is it's a safety key. So when there was COVID around, many people came up with different safety key designs which you use to open the door or press the lift button without actually touching it. So you use this device to do all of those operations. The defense also came up with one, but a lot of other people also. But maybe what's worth mentioning is that with additive, you have this flexibility. So if there is a need that overnight you have to change from making one component to a very different component, it's possible. So it will not take to change an entire assembly line and maybe 10 different programs or things like that, right? So AM offers that kind of flexibility also, which has been leveraged. So again, quite a critical sector, but moving to another sector is again, here we have aerospace. And in our case, I've listed two examples from ISRO, Indian Space Research Organization. They are our pride, nation's pride, and they have been using a lot of additive manufacturing. So the product that you see on the top is made through laser powder bed, and it's quite big, but not too huge. But the one you see below, that is made through direct energy deposition and a really large part. So the benefits that they are reaping there, like I have mentioned before, a small volume, and also they are exploring different materials that can be done. Now, with a lot of startups, both in the sector of space, be it launch vehicles or satellites, or let's say drone startups who are making their own drones, we see that they are adopting additive manufacturing also very high. Their adoption is also very high, right? And the last example that I would like to give you is some of the applications in the industrial and consumer sector. When it comes to industrial, the first picture that I've attached, it's the front portion, like the fender of a car, and they've used VAT polymerization, built it in few segments and joined it together, but it's quite a huge part, right? So be it automotive or tooling industry, oil and gas. So I've tried to club all of them under industrial. But oil and gas, maybe impellers are more important or valves are more important. And for automotive, maybe for prototypes, um, testing prototypes and these kind of applications, right? And then when it comes to consumer, I've put that picture of cuffs. So this is an example of where there was a combination of technologies used, but laser powder bed fusion was also used here. So there was this uncle who wanted to gift his nephew something special, and so he got these cuffs made with the nephew's fingerprints. So you see the fingerprints imprinted there in the middle of the cuffs. So a lot of luxury items, jewelry, all of these kind of things is also starting to, I mean, has been happening in India. Okay, so I would like to also mention about Wipro 3D's contribution in this. So this was a few years ago, but it is still worth mentioning that we printed this particular feed cluster that you see on the right bottom corner, which went into the satellite, um, and GSAT 19, and is still functional. So this happened a few years back, that this was the first metal component that is in the space, and it was printed by us. While I'm very proud of that, why I also want to mention that is because after that we have also certified several other parts for defense, for aerospace sectors. And with this, we kind of have developed the experience and have the knowledge of what it really takes to make components which need rigorous testing, which need certification, and what will you do when there are not many standards existing? So how do we go about that? How do you understand the process variables in the machine or in the process, and how do you control them, right? So these are all some of the things that we have been able to learn and develop on because of such opportunities. And that's us, Wipro 3D, some of our offerings. So we do printing with metal. with polymer. With metal, we have laser powder bed machines in-house. And for polymer, we have MJF, FFF, and DLP printers. We also offer services in terms of additive design and engineering. So if you have a design in mind, you want to adopt the design to be 3D printed, or it's a fresh grounds up design and you want to understand how to do it for AM, then we help you with that. We also have our own products. Last year, November, we have launched our dual nozzle FFF printer commercially. Then we have our DLP 3D printer. This is not yet commercially available, but we also have additive manufacturing labs wherein we definitely supply 3D printers, but we also kind of go around and say what can be done with this machine and how can you skill people using this machine, or what kind of research can you do using these machines, and IoT labs as well with the same purpose. We offer turnkey solutions wherein we will understand your requirements, suggest what kind of machines you may require, procure them, place them in your center, run it for you for a few years, and hand it over to you when you feel it is comfortable for you to do it on your own. We do a lot of AM training and consulting. That is my department as well. And with that, I would like to conclude and open the session for any questions that you may have.